is 3, so we will start now. So I wanted to introduce myself first and wanted you to introduce yourself. So can you introduce yourselves one by one? So I hope my screen is visible and you can hear my voice. Hello. So am I audible? Hello. If you can't say I can't understand, so is there any problem? Okay, so Shubham, so where are you from? Okay, okay. So you're in your lab now? Okay. So this course has started from Monday. So how many videos has been made available to you people? Okay, okay. So what is the last date for the assignments? For the first assignment. Okay, okay. So is anyone else also speaking? Surya, Chandra? Okay. So we can get started. So I will present my screen. Okay. So it's 3 now. Okay. So in this course, so you know the professor who is teaching. His name is Anshuman Roy Chaudhary from Aiza Mohali. So it has started from 25th July, and I will be the TA of this course. And every Saturday from 3 p.m. So in this link in which we are right now, we can communicate, and from next week onwards, I will be answer means discussing the assignments with you. So since you till now you have not submitted your first assignment, so this week we will not be discussing about the assignments. So firstly, whatever questions you have, so when you open this YM portal, so here in this ask a question tab, you can ask any question. So in form of email, or you can attach pictures, or whatever question you have, you can ask it here. And when you ask a question, then I will be able to see it. The professor will also be able to see it, and then we will answer it. And also when suppose I answer some question, so then the others will also be able to see the question and also the answer. So in this way, the doubt which you were having, so it might be that for the others also that my doubt might have been there, so it will get solved. So it will work like this. In this ask a question tab, anytime you can ask any question. So this is not only for Saturday, right? So throughout the week, so throughout this semester, kind of, whenever you want, want, you can ask here, and I will also reply whenever I see it. Okay. So, as you know, so this course is about this chemical crystallography. So, we will be talking about this method of crystallography. So, this means basically we will be talking about crystals and what we are learning. So, in the first week, you have learned, right? So, we are learning about that crystals will diffract. So that is what I want to ask you. So you, any of you, can just unmute yourselves and answer that. Why exactly are we choosing this diffraction? So why not something else? And what is so special about this diffraction technique? So you can answer now. Anyone? So how many people are here? So four people are here, right? So any one of you can answer it. So please unmute yourselves. And this has also been taught to you in your week one. So you should be able to answer it. It is in the beginning classes only, right? So I'll wait for some time. Okay. So basically, if we are familiar with many techniques, like so the most familiar technique is the spectroscopy. So we have learned this from our school level. So we can use spectroscopy, then we can use NMR also. So all these also we can use. But what is so special about diffraction? This is because suppose we have a molecule. So when we talk about chemistry point of view, we will always talk about molecules. So when we suppose have a molecule, and if it has a stereo center, then if it is very difficult to understand the absolute configuration, right? Whether it is R or S. So the absolute configuration is very difficult to understand from simple spectroscopic techniques like NMR, right, or even IR or Raman. So we cannot understand it from those techniques. So what does IR provide information about? It provides information about the bond lengths. It can provide about the different vibrations of the bonds. However, we cannot if we want to know the bond distance, then we won't be able to understand it, right? So bond distances, and also very importantly the bond length. So if we want to know the bond length, we cannot use that technique. So these are the things. And another thing is, suppose you have a molecule and you have a carboxylic acid group, right? So you, it should be carbon with a double bonded oxygen, and another is OH. And then also, suppose you have an amino acid. So you will have a carboxylic acid group. You will also have an amine group, which is NH2 at some other part of that molecule, which we are talking about. However, can we be how can we be sure that it is in the COH and NH2 form, or it has separated into the carboxylate ion and also the NH3 plus? So if we want to understand that such cases, and if it is separated into carboxylate, then what is the bond distance between the carboxyl and the double bond, and also the single bond? Is it both are exactly same, like in we have learned in resonance, or there is a little bit difference there? So all these minute, very specific minute details, for that we need some sophisticated technique. So that is why we use this diffraction. So what is this diffraction basically? So we have learned about we know about the electromagnetic spectrum, right? So we have a wide range of spectra. So starting from the gamma rays, X rays, then we have ultraviolet, we have visible, we have infrared, microwave, and radio waves, right? So this entire spectrum we have, and among this, what we use in a microscope is visible light. So visible light means it has the range of what? It has the range of 4,000 to 8,000 angstroms, and this is somewhat like the schematic of a microscope, and we use this to magnify and see very small objects, right? So very small objects, if we want to see it in a bigger size, we use a microscope. So in the same way, if we have a crystal, then why then we theoretically, so should we be able to see the look inside the crystal structure also, so using a microscope. So there, what do you think? So anyone who wants to comment? 200 to 800, 200 to 800 what? Exactly. So this unit is very important. Always we have to use the unit while saying. Yeah. Hmm. The right, right. That is centimeter inverse. So that is on completely different ends. Actually, so for any technique, second. So this was a question. So actually for any technique, so when we are using any wave, so the size of the objects which we are analyzing using that, so the resolution is limited by the wavelength. So you know what is resolution? So we talk about resolution all the time, right? In terms of pixels and also. What exactly is resolution? Anyone? Okay, so resolution in simple terms, it means with that the smallest distance by which the two particles can be distinguished can be it is like the smallest distance with which the two signals can be separated. So that is the resolution. And if we want to have better images, we want to go to lower and lower the distance, which is kind of called as better resolution, right? So when we are using this visible light, which has this 400 to 700 nanometer wavelength, then if we look at the lowest, this is the 4000 or 400 nanometer. If we divide by 2, we will get around like 200 nanometers, right? So this means that when two particles are separated by 200 nanometers, then that is the minimum resolution which we can obtain with visible light. However, when we talk about solids, and there the atoms which are there, like carbon atom, oxygen atom, so they are separated by like what to say, like in angstrom level. So they are separated by like maybe 2 angstrom, 3 angstrom, like that. If it is CH or OH, it is lesser. So that is why with visible light using a microscope we cannot use, because uh, you know what is the funda of using this optical microscope. So when we are using, so this is like a model of optical microscope which is found in in standard labs. So we have a small object here. So light falls on this object, and when light falls on this object, so then there is a scattering. So we have a lens, and then it is refocused to give a bigger image of the same object. However, when we are using X-rays, so what we are analyzing those atoms which are separated by 2 angstrom or 3 angstrom. So we are interested in the range. So it is in the angstrom scale. However, there is no such lens which has that much basically power to refocus X-rays, because X-rays are very short wavelength. They are very much energetic. So that is why no there is till now no lens which can refocus X-rays. So that is why what we do is we use a computer and some mathematics. So this is what happens in the X-ray diffraction. So we have a crystal of a very small size, and then we shine X-rays on it. Then the crystal will diffract, and then we will collect all the diffraction spots here using a detector. And then we have a computer, we have a crystallographer. So the computer and the crystallographer, so they go hand in hand, using a lot of mathematics to obtain the view of the molecules and atoms, how they are arranged inside a crystal. So how they do is by electron density map, which simply means that suppose you have a molecule, so you can think of suppose very simple, like benzoic acid. So you have all the 6 carbons. So all the 6 carbons in a hexagonal fashion. So they will each have some electron density. So that electron density will show up using the X-ray diffraction, and then we can connect the bonds and we can understand that this is a benzene ring. So in this way, X-ray diffraction is used to view atoms in a molecule which are separated by such small distances. So you have learned about Bragg's law, right, in week 1. So can you explain to me? From here it is apparent, but still I want you to explain to me. So what is Bragg's law? Anyone? So you have learned about Bragg's law in week 1, right? Excuse me. So it was there is supposed to be Bragg's law, right, in week 1. Yeah. So then this is what is happening in Bragg's law, right? So can you explain to me what is happening here? So we have a sample. So this is the sample which we are analyzing. So, and then the X-ray is coming and then hitting the sample, and then there is a detector. So this is shown by one line and another line, 2 lines like this. So what are these angles? So what is this angle called? What is this theta angle? So and if this is the angle of incidence, then what is this is then this is also the angle of incidence, right? Then what is this called as? uh, what is this? Angle of reflection. And then what is this? So if this is theta, then this will become 2 theta, but what is this called as? So this is the angle of diffraction. So we were talking about Bragg's law. So if this is the angle of incidence and then this is the angle of reflection, then this 2 theta, this is the angle of diffraction. So can anyone tell me what is the Bragg's law basically? Yes, hello. Okay. So n lambda equal to 2 the sine theta. And then what are all these terms? What is n, what is lambda, what is d, what is theta? So yeah, so we have to understand, right? So what is exactly? So lambda means the wavelength which we are using, right? And then this d. So what did you say? What is the d between two? So we have this picture, right, for reference. Yeah. So this is not path length. So if we have a ray like this, another ray like this, then the difference, if we drop a perpendicular here and here, then this extra length, this is called as the path length. But this D is not path length, this is called as interplanar distance, which means that if we have a set of parallel planes like this of some indices, so all this you will learn later on, most probably in week 2, this Miller indices, how we name these Miller indices, what are this HK and L, then this importance of these brackets, everything. So we will learn this. So if we have a set of parallel planes like this, then the distance d between any two consecutive planes, so that is the interplanar distance, small d, and that is what is used in this Bragg's law. And then we also have n, right? So what is n? Anyone? No, no. N is not like that, because when we have a crystal, so there are many atoms which make up, which are there in the crystal. So it is kind of like infinite. So we cannot we cannot count how many planes are there. So we call it as infinite. So you have learned that in week 1, so about n equal to 5, and why is that not possible? So that is what's there in week 5. So maybe you have not reached up to there. Okay. So this is what is a crystal. So you can see my screen. Okay, so let me turn my laser. So this is a crystal. So what is the characteristic of a crystal is that it has a periodicity, which means that it will repeat in space. If we consider this as the basic unit, so this box, then we see that this box is repeating in this direction. So this is the x direction, and then from horizontally from top to bottom also. So these boxes, they are repeating. So which means it has periodicity, right? So this is the most important characteristic of a crystal, that it will be periodic. So for this periodicity, what we call as the symmetry operation for this periodicity is called as a translational symmetry. So you have studied that in week 1. Okay. So you have then also studied that if there is five-fold symmetry, then it cannot repeat in space, right? So when we talk about this n, so you will see. So let me just go through. So this is your week 5, right? Five-fold symmetry. So this is your class 5, right? So you have not reached till class 5. Okay, okay. So five-fold symmetry basically means, wait, okay, so now let's not look at the class here. So I'll just explain to you. Okay, so it means that when you have when you have anything repeating, okay, so then if it uh, like for example, if you have, yeah, so this is what, this is a triangle, right? So my screen is visible, right? Yeah. So now if we take one point here, so this point, the vertex, so this is a point, then it is related to these other 3 points by a threefold symmetry, right? So this, if we rotate it, so let me just copy it, and if we like rotate it like this, then we can fit them. There will be no gap, right? Then again we can take this again here. So let me make this of some other color. This is too bright. Yeah. So we can fit it like this. Then again, if we take it, we can fit now. So it means we can continue it along this direction, right? There will not be any space left. Also, we will be able to continue it along this direction also, right? Like this. Then similarly, like this. So when then we can continue along the two directions, we will see this is kind of efficient, which means there is no space left or something. So this means if this is a threefold, then can uh, it can give rise to translational symmetry. So now what about n equal to 4? Means fourfold. So if we think about it, fourfold is more easier to repeat because you can simply arrange them like this, like this, and like this. These will also repeat in this direction, this direction. Okay, so 1 you can easily understand, 1, 2, 3 I have shown you like this. Then for 4 we can do like this. Then about 6, let's see what will be about 6. For 6, what should be the shape? Can anyone tell me? So it should be a hexagon. So I don't know. Hexagon is there in PowerPoint. So I am making a regular hexagon like this. Now copy. So if I do like this, then am I utilizing all the space? What do you think? So there are voids, right? And when in a solid, when the atoms arrange in a solid, so they will always arrange in such a way so as not to leave any void. This is what is known as close packing. We have learned this in school, right? Yeah, so it will not arrange like this. Then how will it arrange? It will arrange like this. So there are many ways it can arrange like this or like this. But anyway, if we go like this, then it will give efficient packing in this direction. And also, suppose if this is my x and this is my y, then it will give efficient packing in this two directions. So this will also this lead to a crystal. So now I want to ask, what about n equal to 5? What do you think for a shape with n equal to 5? So it will be a pentagon. So it will be, yeah. So what do you think about this? Yes. Anyone? So can I arrange it? With, so if this is x, this is y. Right. So let me try. So you can do like this. So what we are doing is, yeah, but we cannot fit anything here. If we try to do it in any other way, then what will happen? Still void will be there. So if there is some shape like this, then will it be able to form a crystal? It should not form, right? If it forms, then it will sort of violate the law of crystallography, right? So let me see if I can make a complete circle. So what is happening? It is going on top of this one, right? So that is why if there is n is equal to 5, then uh, according to the law of crystallography, then it cannot show this periodicity. And if it does not show this periodicity, then it won't be able to form a crystal structure, right? But the question is that can you form a crystal structure where if it is a crystal but it does not have periodicity? So that is the question. So what do you think? Cannot repeat. Hmm. No, unit cell cannot be the whole. No? Unit cell has to be the smallest portion. So have you gone through class 5? Yeah. So then you should all go through class 5. Okay. So after that we will have this discussion in the next video. Okay. Okay. So do you have any questions? So for those who have joined a bit late, so this is the course outline. So it has started, and so each week you will have, I think, like 5 videos or 5 classes, and then there will be one assignment based on it. Then after you have submitted one assignment, then the Saturday after that we will discuss about that assignment. So and this is the Gmeet link. Then also at any time, if you have any question in this ask a question tab, you can go and write. You can drop an email. You can attach pictures, whatever. You can ask here, and I whenever I see it, so then I will respond to it. And then if you have any questions, you can ask, or else then you will leave. Okay, so then we are breaking here.